want to talk to you guys briefly today about graphing in point slope form. We haven't done a whole lot of work in point slope form, but it's something that may come up. It's more just to give you guys a different view on things. So point slope form. So we know the main three that we've gone over, right, is sorry, the main three that we've gone over are slope intercept form, right? We know that one pretty well. Standard form, right? And there is another one that I'm going to show you guys today, and that is going to be what we call point slope form. So it's y minus y1 is equal to m times x minus x1. Now, I don't want to get too bogged down in where it all comes from and where it all works today. So I'm going to show you guys first how it works and how kind of simple it is, because people, if I start explaining why this all works first, you guys gonna lose it. Okay, it's really not very complicated. Okay, if you guys remember from last year, from functional transformations, okay, all we're really gonna have to do is they're gonna give you a point, like xy coordinate, and they're gonna give you a slope. Okay, so an example might be something like this. What if I said, oops, sorry, y plus 1 is equal to 10/3 x plus 7, okay? I know you're thinking like, hey, can I distribute the 10/3 and I'll subtract 1 and it'll be in slope-intercept form? Yes, but the problem is that 10/3 times 7 is not going to give you a nice pretty number. So all you have to do, these two right here, these are your point, okay? All you have to remember to do is, since it's minus here and minus here, you have to flip the sign. So the point I'm starting from is going to be, well, this is the x coordinate, but flip it. So positive 7 becomes negative 7. This is your y coordinate. It's positive 1. It becomes negative 1. Okay, so that's your point. And your slope is going to be 10/3. Okay? So again, where am I starting from? I have to make this graph a little bit smaller. I'm going to start just like the other ones. The other ones we started from the y-intercept, right? But with this one, you're going to see the y-intercept is going to be a fraction. So it's not really an option that we have with this one. So we're going to start from 1, 2, 3, 4, 5, 6, 7, -1, right? And our slope is 10/3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2, 3. And that's you right there. Okay. If I connect the dots. Okay, and that's going to be your line graph right there. Okay. So all you really got to do is flip the signs of these two numbers and then use this as your slope. So it's the same process before, we just won't be starting at the y-intercept. So if you had no problems before, the only thing you really have to remember, flip the x, flip the y, that's your point, and count your slope from there. Okay. If you were wondering why we couldn't just put it in slope-intercept form, I'll show you guys. If we want to put this in y equals mx plus b, which is what most of us are used to graphing in, if we distribute this 10/3, you're going to get 10/3 x, right? No problem there. And 10/3 times 7 is going to be plus 70/3. Okay, and so it's y plus 1. So again, could you subtract 1 from this? Yeah, you could. You could, but graphing y is equal to 10/3 x plus, I think it's 67/3. You can't start from this point. It doesn't work, okay? So we said that there were some limitations to slope-intercept form, so that's one of them, okay? So point slope allows us to graph other points that don't go through an integer on the y-axis, all right? So I'm going to go over 2 more examples, then I'll explain why it works, and then I'll let you guys go. All right. So again, what do we got? We've got y minus 3 is equal to 3/4 x minus 4. Okay? So again, what's your point? Okay? Flip the sign of the x, right? Remember, x is around this side, y is around this side. Flip the side of the x, flip the sign of the y. Okay? What's your slope? 3/4, okay? So where are we starting from and where are we going, right? Big questions. We're starting from 1, 2, 3, 4, 4, 1, 2, 3. Okay, that's my point. Okay, and what's my slope? Up 3/4. 1, 2, 3, 1, 2, 3, 4. And if you actually did this one, I believe this one goes to the origin, right? Down 1, 2, 3. Yeah, it does. This one actually goes to the origin. So if you had converted this one to slope-intercept form, it would have been all right. Okay, so that's you right there. Okay, I'll do one more that tricks people up, even though it really shouldn't. And then I'll explain to you guys why this works, okay? All right, so the last one we'll look at is, again, something that really shouldn't trip you guys up. Y plus 1 is equal to x plus 7. People lose their minds when they see this, right? There's no parentheses on the side. There's no slope. It doesn't tell me the slope. I need it to tell me the slope. It does tell you the slope. The slope of this one is 1. Okay, so people like lose their minds when they see this, all right? There is, in a problem like this, you know, come on, as much as we know this, what if we kind of did that? Okay. Oh, my slope is 1. Okay, so when you just see what appears to be, you know, something equal to something, your slope is 1. Okay. So again, what's your point? Reverse that sign, so -7. Reverse that sign, -1. Do we have that one before? We did have that one before. Okay. And what's your slope? Again, it's 1. Okay. Again, we don't write what, like doing this, multiplying 1 times anything just gives you itself, so it's kind of silly. So if you see one where it's just, you know, y plus 1 is equal to x plus 7, just your slope is 1. Okay, so what are we going? 1, so where are we going? We're going 1, 2, 3, 4, 5, 6, 7, 1, and then what's your slope from there is going to be 1. So your slope of 1, you guys should all be very familiar with, right? Corner to corner on the boxes. Oh, I got an email. Okay, and just go ahead and draw the line. Okay, so again, that should give you enough information to go ahead and get started on the IXL stuff. So if you are good with that, again, just flip the X and Y and then go for your slope from there. All you're doing is the same thing we were doing the other day, just starting from a different point. If you're curious as to why it works, stay tuned and I'll explain to you guys how it works. Okay, so where does this equation come from? So where does this equation come from? It's the slope formula. That's all it is, right? What was your formula for slope? Dig back real hard. Your formula for slope was m is equal to what? y2 minus y1 over x2 minus x1. Okay. Thing is, now we know one of the points. They're going to give you one of the points, right? I'm going to multiply this side times x minus 1. x2 minus x1, multiply both sides by x2 minus x1, what am I going to get? y2 minus y1 is equal to m times x2 minus x1, okay? And they flip them around up here, but these are the same thing, right? So all this is the slope formula. So I'll go ahead, I'll switch these around. y2 minus y1 is equal to m times x2 minus x1. The only thing that really changes is they're writing this as a general formula. They're not writing it as slope formula. All right, well, there's you right there. Okay, so all this is the slope formula. There's no big deal about that. Okay. All right, why does it work and why do we have to flip the signs? Okay, well, you should understand now like why the slope is where it is. Okay. If you think about last year, what we talked about solving quadratics and setting things equal to 0 as our best friend. Like it was a way to make the impossible possible to a certain extent. if I put two numbers in here, let's put two numbers in here. Y minus 5, y plus 4, okay? Again, what would make this equal to 0, right? Well, wouldn't it be -4? Wouldn't it be whatever the reverse of this sign is? So what if I said x equals -4, right? Well, it actually doesn't matter what your slope is because -4 times 4 is 0, and 0 times your slope would just be 0. On this side, well, if I want this to be equal to 0, then I need to have 5 here, which is actually just the reverse of this one right here. 5 minus 5 is 0, right? So in fact, what you did was you just found a coordinate on there, right? This is true. This makes this side equal to 0, right? This x makes this side equal to 0, and this makes this side equal to 0, and that makes our statement true. So if we plug in those two numbers, again, I'm going to leave the slope as m because it really actually doesn't matter what the slope is. So 5 minus 5 is equal to m times -4 plus 4. Well, this is 0, and this is m times 0, which is 0. Okay, so you have a point that satisfies the equation. That's just where you're going to start from. So all you need to know is I'm starting from -1, 2, 3, 4, 1, 2, 3, 4, 5. Then whatever your slope is, you just take it from there. Okay. So like I said, the benefit to this is it gives us a way to start when our y-intercept is not so cut and clear. So again, like I said, if you want to know why it works, that's why it works. But I mean, bar none, flip the two signs and start from that point as your slope. Okay, so I hope this helped. I'm gonna give you guys some problems to do, get them done, and yeah, we'll talk about what this means for geometry next week. All right.